So who has a question either from the review or any materials that we used throughout class that they would like to see worked out?
I just had kind of a more general question about the test.
Mm-hmm.
So, well, two actually. So, how long is it just standard time for the final? 2 hours and 3 minutes.
I mean, if you guys need 3 hours, we can do that.
Okay. And we're still using just a regular posted or not posted index card.
You can have a whole sheet of paper for this test.
All right, cool. I'll give it a shot.
Okay.
Also, can I use like the little whiteboard thing?
Yeah, go ahead.
I will need your it says host disabled screen share.
Okay. Yeah.
All right, let me just get this in the little corner so I can see it.
And the rest of you feel free to, uh,
Annotate.
yeah, you can help out, annotate, make suggestions. So while you're starting out this problem, I'm going to go ahead and calculate your guys' grades for you up until now.
All right. So for this one, it's gonna be definitely like the fractions type problem. So what we can do is find the make this factor this. So it'll be something like I think it was x minus 2 from x and x, I believe that'll be also minus 2 or minus 1. So if we solve that, so get x here and here. So make this 2x and x. So that'll be x to the power 3 negative x squared. We have 2 minus x squared. And then we have plus 2x, which is equal to x3, 3x squared plus 2. So it matches. So that means that's what we can use. Just go get this. Actually, I'll just keep that for until I have to remove it. So that means that the integral of this so these two equal. So we could write it now as x squared minus 2x times x minus 1. Then we can have a over x.
Wouldn't it just be x minus 2?
I'm sorry?
Never mind.
Okay.
Keep going. Sorry.
No, you're showing. Um,
You,
Hold on, I don't think it's x
one, yeah, you're supposed to take the 2 off for the x squared and the 2x.
Yeah, it's just x minus 2, right?
X minus 2?
Yeah, because you added in the x,
Mhm.
so you just need to leave it how you had it on the top, but not add the 2 for the 2 squared, and then you need to remove the x for the 2.
Oh, yeah, my bad. I'm sorry. Yeah, because I was looking up here and I missed. Okay, I got you. Thank you. All right. This will be x minus 2. What is a b? Not 1. Then we have x minus 1. I'll see if we can make a little bit more room. And then we would solve just by multiplying the denominator. So that'll leave us with 1 equals a times x minus 2 x minus 1. Then we would have b x times x minus 1 nope, not equals. There you go. Plus c minus 2. We're all good. We're all on track so far.
Yeah.
Are you asking everyone?
I was asking the group, see if anyone was lost. All right. Now in this case, so we can just let's try to find a. So what we can do is make x equals 0. So if we do that, we would have a negative 2 times negative 1. So that's end up to be 2. We'll simplify that too. But for b, it'll just be 0 because 0 times negative 1 is just 0. In the same case for c, so that's just 0 multiplied by negative 2. That also equals 0. And then, so if we solve for that, that'll be 1 equals, so these two make just positive 2. So if a 2, then if we solve for that, we just divide by 2. So that would mean a is equal to 1 over 2. All right, so let's go put that up here for safekeeping. Now we do the same thing to find, let's find b. So in order to find b, let's do 2. So instead of 0 this time, we're going to use a 2. Because that should make this into a 0, and this should make this into a 0. So a would be 0 to negative 1, which should just end up to be 0. B would be 2 times 1, which will end up to be 2. And then c would be 2 times 0, which will just end up to be 0. So here, got 2, we have 0. So now we're left with 1 equals b2. And it turns out this would just be the same as a, so that would be b is equal to 1/2. Now for the last one, we want to find c. So in this case, we should probably make the x, erase this. We should probably make the x, we can make that 1. Because that's going to cancel out this and this. It's going to make them zeros.
Go ahead and keep working, Dan, but I just wanted to say to you guys, I have your current totals figured out. So if any of you would like to know how many points you need to get to a certain grade, just send me a message in the chat and I'll return that total to you.
Okay. I'm going to go write that real quick. Give me a hot second.
So look, A and B are going to disappear, right?
Yes.
And you're going to get C times, looks like -1.
Yes.
So C is -1.
So C is -1. Just like you said, if you put in 1 here, that's just 1 times -1. That makes sense. This would be 0. That would cancel out. This would also be 0, and that cancels. So we're only left with 1 equals C -1, which means C, I guess just put this up here. C is equal to -1. All right. I'll hang tight for a sec. Okay. So, gotta get rid of this. So now we know what A, B, and C are, so we can just write that 1 is equal to, so A is 1/2, so that'd be 1/2 over X. B is also 1/2, that's over X minus 2. Then C, which is -1, is over X minus 1. So now, what we do, I believe, is take the integrals of those. So, I'm gonna make a little bit more space up here. Because now that we just have it written down. So for this one, it could be, you take the 1/2 out, so it'll be 1/2 integral 1 over x dx plus 1/2 integral 1 over x 2 dx plus, that would be the negative integral of 1 over x minus 1 go remove this little red squiggle real quick. Okay. There you go. Now integration at this point should be pretty easy. So that would equal not much room, but I'm gonna get rid of this real quick.
What's that?
I'm just erasing some work.
You can add another page.
Can I?
Yeah, there's a little button down the bottom right.
Bottom right. Oh my god. Okay. I think. Hold up.
Go ahead and finish that problem so we can get to another one.
Yeah. I'm trying to get back to the previous one. There it is. I see it. Okay. Cool. I'm almost done. So it will be. So the first one would be 1/2 ln x plus 1/2 ln x minus 2 plus negative ln over x minus 1 plus c. And that's your answer.
I'm gonna keep up with all these questions. All right, everything look good?
I'd say.
Well, of course you're gonna say that.
I may be a little biased.
It looks good to me.
All right, anybody else have another problem they would like to work out?
I'm just going to clear this. Does anyone else still need or want to take like a screenshot of it? I mean, it's going to be recorded, but you know. Are we all good? Going once, going twice. Yeah, we're good. All right, cool. No,
We
sorry.
do can we do number 14?
What is 14? Just curious.
It's find the interval of convergence of power series.
Okay.
Yeah, I was gonna ask if we could do that one as well.
Probably a smart one to work out. All right. Where am I at here?
Is it question 14?
Yes,
I can try.
that'd be great. Thank you. there anybody I haven't answered yet on the chat? Because it's starting to get a little confusing.
Me.
Okay, give me a second.
Okay.
I know some of you asked the final is 120 points already, and then there's 15 bonus points at the end. So you have an opportunity to earn 135 points. So Shriyam, you have not done anything wrong. I just want you to be careful that when you're crossing out these functions, so the 3x minus 2 to the n, that whole thing gets crossed out, that's fine. But the 3x minus 2 to the n plus 1, you would just cross out the n.
Okay.
Because if you cross out the whole thing, it looks like it's all gone. But then all of a sudden, on the next step, you still have some left. Do you see what I'm saying?
Yeah, got you.
All right, so at this point, you've got 3x minus 2 over 3, right?
Yeah. And in the opposite, it's gonna be n upon n plus 1.
And when you take the limit of that,
Mm-hmm.
you get 1, right? Because you divide everything by n.
So it's gonna be, I think, minus 1 and 1.
See, while you're doing that, I'll just do the little intermittent steps for you.
Quick question. So, for like you have a 3x minus 2 over n plus 1, 3 times n over 1. Where did the n
Which n?
go? On the second limit you wrote down, the n over 1. Where did that get canceled out?
You divide everything by n.
Okay, and then those two cancel.
Yes.
Okay, thank you. And Dr. Perkins, it's okay. A little later, once we get most of the review questions, or get a couple more in, if we can go over stuff on test 2.
Does it have anything to do with the type of problems I tell you or told you you'd be doing for the final?
Yes. Specifically, I think you said question 4. Approximate the function by setting length of arc length, then approximating the integral.
Okay. So this is the point that I saw most people make their mistakes. And I don't know why it is, but every semester people just want to make everything an alternating series and show that it's decreasing and take the limit as n goes to infinity. But not everything that comes out of these is an alternating series. So you just take the number you solve for. So she's taking negative 1/3 here, plugging it back into the original. So 2 times negative 1/3 minus 2. Or so that should be 3. So it's a 3. 3 times negative 1/3, so that's negative 1, right? Minus 2, so shouldn't this be minus 3 on top? Oh, okay, you already simplified. Gotcha. So yeah, it was minus 3 on top. So that's minus 3 to the n over 3 to the n. Those would cancel, leaving behind a minus 1 to the n. Now, ironically, this one is alternating. So we do need to show that it's first decreasing and that the limit goes to 0. And don't always just draw that shape. Make sure it looks like what the thing actually looks like. It is 1 over n, so it does look very close to that. And then very easily we know that limit of 1 over n goes to 0, right?
Because it's going to be 1 upon infinity, so it's going to be 0 and it converges.
So that the left point converges, which means you include the left point.
How did you get rid of the power to the n in the denominator?
So she didn't write the step. Where did my pen go?
There's no space.
Give me a second. Oh, there we go. So in between the equal sign there, she would have had negative 3 to the n over n times 3 to the n, which if you like, you can write as negative 1 to the n, 3 to the n, which means these cancel. And you're left with what she has down here. Did that answer your question?
Yes.
Okay, so your 3 to the n's cancel on that one, right?
Yeah, so it's going to be summation of 1 by n,
And we should recognize that as
a harmonic. Like I
right.
have used the harmonic series.
So you can literally just write harmonic series,
Yeah, and it diverges.
So see that side, we didn't show that it decreased and take the limit, right? Because it's not an alternating series. I saw that so many times. It's not always the answer.
For the left side, is it left off as 1 over n? Like the right side, but then wouldn't they both be harmonic?
The left side is an alternating series. And for alternating series, you take the absolute value of a sub n, which makes it look like 1 over n. So you do all of your actions with the positive piece, but it's still an alternating series,
Oh.
right? All
So,
alternating series, we always take the absolute value, and they're no longer alternating.
so for the bottom, when she writes left, and then that thing under left, and then right next to it, and it says a summation of -1 to the n over n.
Mhm.
Are you saying that the absolute value of that is 1 over n?
Yes.
Okay.
Yeah, I think you got your symbols backwards. We found that the left was convergent, the right was divergent. So the right side needs a parenthesis, not a bracket.
Oh, sorry.
All right. No, the left was correct.
Mm-hmm. This one.
Yeah. Right. If it diverges, it needs the parenthesis.
Mm-hmm.
Any questions about that problem?
So I shall stop sharing.
Yeah, go ahead. How are we doing so far with the review? Good, bad, don't like it?
Good.
Okay.
It's
Well-
not too bad. I was just trying to see like what was on the test or what was on the review that's like going to be on the test now.
Right. So, any other suggested problems that we should look at? If you like, I can run to the review really quick and say.
Can we do 19?
18.
It's with a parametric equation.
Yeah, you can do that one. The only part that I did not necessarily say you'd have to do is the arc length part. So if you just do A and B, that'd be fine.
Okay.
Somebody want to try that one? Nobody likes parametrics?
I could try.
Yeah, but you just did one.
Yeah.
I could do it, but then I feel like I might do it too fast.
I can try it.
All right, go ahead.
Okay, so the question is,
Would you like me to read it to you so you can write it down?
yes, please.
The parametric curves are x equals 1 plus 2t squared.
Is that like in parentheses?
Just the t is squared.
Gotcha.
And then we have y equals 2 plus 4t cubed. Again, just the t is cubed.
Okay.
It first has to eliminate parameter, find tangent line at t equal 1, and increasing and decreasing.
Okay. So I'm looking at my notes because like I'm still not confident with parametrics, but eliminating the t, we could solve for t, right?
That is one method, yeah.
Okay. So all right, so with x minus 1 equals 2t squared. So I could divide by 2 and then take the square root of that. So then I could plug this into the equation with y, right?
Yep.
Okay. So then y equals 2 plus, I'm going to write this as x minus 1 over 2 to the 3 halves.
I think you missed your 4 in front of that.
Thank you.
There we go. Okay, so that's y is a function of x.
Okay, so then it says, okay, so I didn't graph using a table of values. Let me do that. So t x and y. So when t equals 0, x equals 1 plus 2 times 0 squared, so x equals 1, and y equals 2. When t equals 1, 1 plus 2 times 1 squared is 3. And then y equals 2 plus 4 times 1 cubed equals 6. And then 1 plus 2 times 2 squared. So 2 squared is 4 times 2 is 8 plus 1 is 9. And then 2 cubed is 8 times 4 is 32 plus 2 is 34.
We're already getting pretty far up there.
Yeah. So let me, oh
Here, I got you.
thank you. All right, so 1, 2, put a dot there, 3, oh, that's, no, do 1, 2 down here, 3, 6, and 9, 34. So is it going to be like an exponential curve?
If we look at the form that you wrote down here, what's it look like? We've got x to the 3 halves, right?
Okay, yeah.
Plus some other stuff going on.
Mm-hmm.
So yeah, it should be somewhat exponential.
All right, so connect those, and then the arrows are going that way.
Okay.
And then B is find the equation of the tangent line at t equals 1. Find where the curve is increasing and decreasing. So the slope of the line tangent to C, where C is a parametric curve, is defined as, okay, the derivative. So
Now you can do this 2 ways. You could take the derivative of the y equals equation there, or the way that we learned to do it was do dy dt divided by x dt.
yeah, I'm probably going to do that one. So dy over dx equals dy over dt over dx over dt.
Mhm.
So dy over dt is 12t squared. And then dx is 4t. So dy over dx, 12t squared over 4t. So this cancels with this t, and this cancels to 3. So this is 3.
Christina, quick question.
Yeah,
What you just wrote, what did you're 12 on the top where you're 12t plus what?
it's 12t squared. So I wrote what dy over dt equals
Oh, 12t squared, and then you, okay.
over
I see it.
4t.
Thanks.
Yep. So I believe that's the answer to the equation of the tangent line at t equals 1.
Well, that would just
So
be
what I
slope.
Oh, okay. So
So plug t equal 1 in.
into the slope, like 3t.
Yeah.
Okay.
Super hard, right?
Yeah. So then the slope equals 3.
Slope is 3. And then to get the x and the y coordinates, you need to plug t equal 1 back into the x and y equations.
Oh, okay. And then do like y minus and x minus.
Yep, your point slope formula.
Okay. So at t equals 1, x equals okay, so we did this 3 and 6. So y minus 6 equals 3 times x minus 3. So 3x minus 9 equals y minus 6. Add 6 to both sides. Y equals 3x minus 3. Okay, so that's the equation.
Dr. Birkins, can we leave it in point slope?
You mean leave it as y minus 6 equals 3 times x minus 3?
Yeah. Or do
If
you
we-
want it in y equals mx plus b? Sorry, I didn't hear you.
I said if you want to be lazy and lose a point, sure.
Alright.
Okay, so then where the curve is increasing and decreasing. Oh, this is the first derivative test?
So you've already taken the first derivative, right?
Oh, okay, yeah. 3t.
3t. So you just need to find out where is it increasing and decreasing. So first you need your critical value.
Yeah, okay.
Again, it's super easy.
So it's just when t equals 0. So when t equals, so for this, would we do a value where t is greater than 0 and less than 0?
So if the problem doesn't necessarily give a restriction on t, either given in the problem, or if we look back here at the functions, right, x and y, we can plug any value of t in there,
Mhm.
and it's okay, right?
Mhm.
So in that case, you're allowed to have negative t's. So yeah, you would test those.
Okay. So say t equals -1. And then do you plug that back into the derivative or the original equation?
You always plug that value into the derivative.
Okay, so 3 times -1 is -3, so that's negative. And then t equals 1, 3 times 1 is positive. So decreasing from negative infinity to 0. Would that be a harder or soft bracket? Well, okay.
Never include the points, because at those points it's 0.
Right. Okay, that makes sense. So decreasing and then increasing from 0 to infinity.
Looks good.
Okay, sorry, that took me a little bit. Parametrics aren't my strong suit.
Well, I think it's not a lot of people's strong suit. That's why we went through it.
All right, does anyone need me to leave this up? I can leave it up for a little while.
At least leave it there until somebody else throws out another question.
Okay, sounds good.
Could someone do 1D?
I can give it a shot.
But didn't you already do one?
Who's counting, you know?
I am.
Yes, I did. So,
All right. Let's get somebody else in here then.
Sure.
Want to give it a shot? Going twice. Oh, it's much better. All right, then. That's it, right? Yes, no, maybe.
I can't see it.
You can't see my share?
No.
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 You have to go to the top and it says which screen you are viewing, and then you have to select Dr. Birkin's screen. It should
Okay.
say like view options.
Yep, I saw it. Thank you.
Yep.
Everybody good now?
Yeah.
Yeah.
Let's see. So it's a sine and cosine problem, which means we need to break off one of them. There's more cosines than sines, so I'm probably going to let u equal cosine for the problem. which means du is going to be minus sine. So I'll break off one of the signs, and I'm going to throw a negative in there as well, because we need that. And if I do that, I got to throw one outside. So then I got to change my sine into cosines. So sine to the fourth is going to be what?
You can make that sine squared.
Okay. So this would be 1 minus cosine squared
Oh,
squared, right? If I made the correct substitution. And so at this point, I have u to the 17th times 1 minus u squared all squared du. Multiply out that binomial, then distribute the u to the 17th. And if you really want, you could take that negative back in and make it, no, I'm not worried about that. Let's leave it out there for now. So this is, darn it. This would be u to the 18 over 18, and instead of u, it was cosine. So should look something like that.
Wait, what happened to your 2? Like 1 minus 2u squared. I missed something.
This two?
No, down at the bottom. Yeah, that right there, that 2.
That two.
Okay. Thank you. I didn't know if I was going crazy or
Always. So you guys good with that?
Why is it 10 on
Why?
the denominator?
Because there was a 2 there and I divided by 20, so 2 over 20.
Okay. Thank you.
Mm-hmm. Am I okay to erase this?
Yep.
Okay. All right, what else we got?
Could you do number 7?
The arc length problem? Is that what you're asking for?
Please.
Let's see, log of cosine. Was it pi over 4, I think, was the bound? So we really just need f prime. So derivative of natural log is 1 over the inside times derivative of the inside. So this is negative tan. You would plug that in here, squared. So now the question is, do we have an identity for 1 plus tan squared?
Secant squared x.
Right? So that'd be under the radical. So then the squared and the square root would cancel. Darn it. Get out of here. And you'd end up with secant dx, which is probably where the confusion set in, I'm assuming. And that's a problem that you can do most easily if you know the answer already, unfortunately. So this one was natural log of secant plus tangent. And whatever those values come out to be.
Root 2 plus 1.
What's that?
For secant pi by 4, it's root 2, and it's gonna be plus 1 for 10 pi by 4. So it's gonna be ln root 2 plus 1.
Is that what you said?
Yep.
And then tan of 0 is going to be 0, and secant 0 is 1. Natural log of 1 is 0. Right? That help, or did I do it too fast?
Yes, thank you.
Not a problem.
Could we do 18?
Yes, one of you can. That would be a good problem to do. So anybody that hasn't volunteered willing to do problem 18. All right, how about Connor? Would you like to do 18? Oh, never mind. Anna's already doing it. You're saved, sir.
Thank you, Hannah.
Welcome.
Looks like we lost a couple of participants there. They're all trying to get back in. If you need me to help you draw something, let me know.
Okay.
Now, what's that little squiggle supposed to what does that mean?
It's like equals.
Okay. Thank you.
Approximately equal to.
Yeah.
Okay.
So what I did here was I put in x squared in for x to get this summation for the series given.
And so that just simplifies to x to the 2n, right?
Yeah. And since we need the first 6 terms, we start with n equals 1. Up to n equals 6. And then we plug in the values for n into this summation. once we plug in the values for n, we get this column of numbers. And then once we simplify that, we get this column of functions. Then we write the integral. From 0 to 0.2.
So while Hannah is plugging these in and about to integrate, can someone tell me the reason that we only need 6 terms here? Or why use
In
this?
question, it's given that we need 6 terms.
Well, no. So what I'm saying is why is it okay for us to use an approximation at all in order to solve the integral?
Because like as we, so the big, or the n equals 6 is the term x to the 12th, like that's a high exponent, and the exponent is only going to get larger, and our upper bound is 0.2, and as we like continue to raise that to a higher exponent, it'll get smaller and smaller.
So good. The values of x are really small, right? And remember I said that these approximations are really only good as long as the value of x is small. So good. You guys learned something?
Don't speak too soon.
Don't include everyone in that sentence.
Yeah, I don't know if you could just lump us all together.
So could someone go ahead and start calculating that number while she's writing down all these integrations? And recall that you don't really need to plug in 0 because all of them would go to 0.
Yeah.
I got this coming out to 0.0026526 oh 23.
What's the ooh mean?
That 6 is really weird.
That's what I got too.
Yeah, and then when I did the like FNINT, I got that exact number as well.
Well, look at you guys.
So Dr. Birkins, this is the type of problem that would be like number 6, where you said 3 parts, integrate the function, and then use the power series to use the first 3 terms to approximate it.
Well, integrate the function means you'd have to have a function that you could actually integrate by hand, because I don't want you to just plug it in the calculator and kick out a number.
Yeah.
Then the second part you said, it says prove the series.
Yeah, here's a power series, prove it.
So that would be like, for this problem, we had natural log of 1 plus x given there.
Yeah.
To prove that, you would need to use the Maclaurin series.
Okay.
So do the Maclaurin for it. Prove that you get the summation on the right-hand side. And then once you've done that, then take the first couple terms, plug them in, and integrate again.
Okay. So basically, are we trying to see that the approximation matches the integral that we solved before?
That is the hope, yeah.
Okay.
In this case, would you use the Taylor because it's not centered at 0? It's ln 1 plus x squared.
No, that's when you do a Taylor, you're expanding about a point. That's something different than if you're trying to find the power series representation.
Yeah, because there's no a, right?
Well, there is no a given in the problem.
Okay.
I see what you're saying, Dan, but that's not exactly the situation.
Okay, I'm just curious. So in this case, like say if this was the test problem, we want to be given like, oh, this is approximate to this. We would have to find that, or at least we're given the equation, then find the integral, and then we would be given the approximation.
What approximation are you saying that you have to find?
I mean, well, in this case, it's kind of given to us, but this would be the sequence of -1 to the power of n plus 1 times xn over n.
So that's the power series representation. And that would be both given to you, and I would ask you to prove that it is true.
And you would prove that's true just by integrating ln 1 plus x squared.
No, you would prove it's true by doing the Maclaurin series of natural log of 1 plus x.
And basically showing that you get the same pattern that you would as the series, because then they equal each other, and then you can use that to find the next 3 terms.
Right.
I gotcha.
All right, so we still got about, or just less than 40 minutes left. Any other questions you guys would like to look at?
How about question 20?
What is that asking?
It's the polar equation to Cartesian.
Okay. Have you solved one yet? I think you did.
Are you asking if I have?
Yes.
No, I've asked about one before.
All right. Do you want to try to do that one?
Sure. So we can use the fact, or we can convert the cosine theta and sine theta to Cartesian using the fact that r equals x cosine theta and r equals y sine theta. So then you have cosine of theta equals.
You got your R's in the wrong spot.
Oh yeah, they're flipped. There we go.
There you
About
go.
to write it, and I recognized it was upside down. We have x over r, and then sine theta equals y over r. And we can plug that in. Times x over r.
Okay. So now you've got common denominator of R on the bottom.
Right. So then we have r equals 1 over 3. Oh, it's 2. Is a 3, trust me. So then we can flip the, yeah. So dividing by a fraction is multiplying by the reciprocal. So r equals r over, keep writing 3. 3.
Okay. So now if you were to divide both sides by R, what would you have?
We'd have 1 equals 1 over. Now I'll just write it. 1 equals 1 plus 3. Multiply that over. We have 2x plus 3 1.
Mm-hmm.
And then for these problems, do you want us to solve it for y and have like y equals?
Yeah, you might as well.
Okay.
Now, of course, if it's a circle or something like that, you can leave it in the form of a circle, which is, you know, x minus h squared plus y minus k squared equals r squared.
Okay.
But if it's a line, you know, you can solve that for y equals.
Okay.
Whatever the normal format should be for that type of function. There you go. That's another problem that you can expect to see, something like that.
They said that you may change it. That you may change it to instead of Cartesian to polar, and the other way around. Like you you said you might change it to changing a function.
I think what he was saying was that he was just gonna do coordinates, so you just have to convert the coordinates, but instead of that, one of the conversions will be a function like we just did. Like this was a function, not a point. It's not gonna be like this is a point, here's this. Convert it. But this one of the questions will be a function.
Okay, I
Did I
got you.
understand that right, Dr. Perkins?
Yes.
Okay.
All right, cool.
All right. Anything else that you guys would like to see?
I mean, we can do a volume of revolution because I think that's one of the only ones we haven't done that's going to be on the test. If people want to see that, I mean.
That's either problem 3 or 4. On the review.
Does anyone have a preference?
I'd say do 4 because it's about the line of x equals 5, which I think we've had less problems of like that.
Yeah, I was about to say 4 too.
And I personally would suggest doing both. I think we have plenty of time. Somebody want to tackle the first one?
I'll do the first one.
Okay.
I just have a quick question. Isn't shell method is around the x-axis and washer method is around the y, correct? Or is it the other way around?
Shell is about the Y.
Okay, so then disk and washer is about the x.
Typically, yes. Doesn't have to be, but those are typically the way that it works out. Yeah, my neck's hurting staring down at this computer.
Alright, let me just. So the formula is the volume equals pi integral a to b uh, where yeah. So hold up, I just need to find the problem real quick. There we go. Alright. And this is number 3, so volume would equal pi integral. I'm gonna leave the bounds alone until we solve where they intersect. And based on the graph. Hold up. Let me pull up a graph of it real quick. Three x squared and x. So they intersect after graphing it at 0 and 1/3. And the graph. Okay, that's terrible, but it will do. So you're solving for the area in between those two, and since it's top minus bottom, if you have two functions, it's just f of x squared minus g of x squared, and f of x being the function on top. So then it would be x squared minus g of x, which would be your second function. Thank you. Which your second function is minus 3x squared, and then you square each one individually. Dx. So now that you have your integral set up, you just solve the integral. So you would have equals pi times 1/3 x cubed minus, that would be x to the 4th. So you would have 3. This is getting ugly. X to the 5th.
Don't forget to square the 3.
Oh, thank you. So 9, and then that's evaluated from 0 to 1/3. So 1/3. So then you get 1/3 whole thing times pi. 1/3 times 1/9 minus 9.
So how did we get the 0 to 1/3 bounds? Did somebody solve this?
I graphed it on a graphing calculator and then just looked where the two functions intersected.
Okay.
Is that a acceptable way of doing it, or like would solving it be better for like a test?
For the test, I would like to see how you got it, but certainly that is an acceptable way to get it.
Okay.
It only takes maybe 10 seconds to solve that.
Yeah. And then it's minus 0 because both terms be 0. Close the parentheses, and then
Would that 1/9 be 1/27?
yes. I can't do math. I'm sorry.
Oh no, you're all good.
I just multiplied it by 3 and didn't actually cube it. So then times 3, you get 1, 8. That is not an 8. 81 minus 3 times 3 equals 9/5 times 1/2, 3 And you get 9 over. And then, yeah, you just find a common denominator with. Let's see. Yeah, let's see. Is there a common denominator here? Okay, so yeah, you just.
According to the calculator, it comes out as 2 over 405.
2 over 405?
Yeah.
Times pi, obviously.
Yeah. Over 205?
405.
405.
Thank you. Are there any questions on how I got there or anything I did?
All right. Anybody want to take and try 4?
I can try number 4.
All right, go ahead.
All right. So what is it? It's f of x is equal to x minus x squared.
Yeah.
All right. So when I went ahead and graphed it, I'll go ahead and show that it looks somewhat like a upside down U, if that's the point 1, something like that. And if we need to revolve it around x equals 5. Go ahead and draw to 0.5. So 2, 3, 4, 5. And then it'll just be the same thing next to 5. There's our line. And so if we put it together, it would look kind of like a washer. So to solve for the two bounds, we'll set this equal to 0.
So Connor, that the if the first part of the curve is 4 units away from the axis of rotation,
Uh-huh.
the other part should be 4 units away.
Oh, okay, my bad. So we need to go down to like something like there, right?
Yeah.
Bigger washer.
So the way that I like to think about it is it looks kind of like a bagel
Uh-huh.
that's been cut in half. That
Yeah,
would,
because if it was right at the 5, it'd be a very smushed bagel.
I mean, this
All right.
one's gonna have a really large hole in the center, but that's kind of the shape that you're getting out of it.
Yeah. All right, so then
So
you can
yes,
take an X out.
it kind of looks like a washer, but be careful saying that
Uh-huh.
because that would make a lot of people think, oh, I need to use the washer method.
Oh, okay. So we can just call it a bagel then? Is that better?
Sure.
Nice.
Time to solve the bagel problem.
Yeah. All right, so then we have what is that? X is equal to 0 and 1.
Yep.
Nice. Okay, so looking at this graph, if that's the radius right there, I think the volume is 2 pi out in front.
We're using cylindrical shells, so we need 2 pi times the radius.
Yep. And so the radius would be, because it's around the point 5, it'd be 5 minus x.
Yeah.
And then the height of it is
Just be the height of the
minus x squared dx. Yep. That's r and that's h.
That was my fault.
All right, and then so now we can just multiply the two inside terms together.
Mm-hmm. So again, these problems, the hardest part is the setup. Once you get here, it's not hard to multiply this out and integrate.
Yeah. If I can do math, that should be right. And then we're going to go ahead and integrate.
Personally, I would say you've got minus 5x squared minus another x squared.
So do 4x, or minus 6x.
Minus 6x, yeah. Weird.
I guess we could even simplify that right there. We'll just make it, let's put a 2. And then plus x to the 4 over 4 from 0 to 1. So then we'll have 2 pi times 5 over 2 minus 2 plus 1/4. Then it should be minus 0, minus 0. Let me see what that comes out to be.
I think it would come out as 3/4.
Yep, You're
if
right.
I can do math.
All right, and then all in all, that should be 3 pi over 2.
All right, guys. We still got 12 minutes. You're free to work out some more problems if you like. Just wanted to check and make sure everybody saw my message on the chat. All right, today's the last day before the final, so if you have any questions whatsoever, contact me, get a hold of me somehow through email, hopefully. Set up a time if you need to go through some problems, whatever. I'll try to make myself available just about all day today, but I do have a few things that I need to get done. Any questions for me about the test, anything like that?
Just to clarify, there's nothing really on work on the test.
Currently, no. There is nothing, or there are no work problems.
Okay.